In this short video, we are going to look at an example of sampling with replacement. So we're going to assume we have a shipment of 40 fuses, and in this shipment of 40 fuses, 15% will be defective. That is an assumption we make because the fuses from the manufacturer tend to have a defective rate of 15%. We're going to randomly sample 4 fuses with replacement. So this means we select a fuse, test it to see whether it is defective or not, then replace the fuse in the box, mix them all up, and select another fuse and see if we test it to see if it's defective or not. So it's possible we can pick the same fuse more than once. Whenever we sample with replacement, all the events are independent, which means then that the probabilities are constant. So every time we choose a fuse with replacement, the probability of its being defective is 15%, and so the probability of it being good is 100% minus 15%, or 85%. So in this first question, what is the probability that none of the selected fuses are defective? That means we want to find the probability they're all good. If none are defective, they're all good. So we're going to find the probability of good, 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 good. Think of that as the probability the first one is good, and the second one is good, and the third one is good, and the fourth one is good. So what we have here then are AND problems, and we will be applying the product rule. So the probability the first one is good is 85%. That's 0.85. Now the probability the second one is good is also 0.85. And the third and the fourth, those probabilities are also 0.85. So we're going to have 0.85 times 0.85 times 0.85 times 0.85, or more simply 0.85 raised to the fourth power, since this probability will be multiplied by itself 4 times. So the probability that none of the fuses are defective or that they are all good is 0.522. Now let's find the probability that all 4 fuses are defective. So the probability of defective, 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 defective. So we know the probability that each one is defective is the 15%. So the probability the first one is defective is 0.15, as well as the second, third, and fourth. We will be multiplying these all together, so this will just be raised to the fourth power. And so 15% to the fourth power. Notice I don't need parentheses when I'm working with decimals before I raise to the power the way I needed the parentheses when I was working with fractions. 0.15 to the fourth power is 0.00051. Now we want the probability the first 2 are good and the last 2 are defective. So that's the probability that of good, good, and defective, defective. So we see the first 2 are good. The probability of good is 0.85. We have 2 of them, so we'll square it, times, that's the AND, the next 2 are defective, so 0.15, there are 2 of them multiplied by themselves, so we can square that. So the probability the first 2 are good, 0.85 times 0.85, times the probability the last 2 are defective, 0.15 times 0.15, or more simply 0.85 squared times 0.15 squared, which gives us 0.01626. Now what about the probability the first 2 are defective and the last 2 are good? So the probability of defective, defective, good, good. Will this be any different? And you'll probably realize the answer is no, because we will be multiplying the same numbers together, only in a different order. The probability the first 2 are good is the 0.15 squared, and the probability the last 2 are good is 0.85 squared. So the probability the first 2 are defective, 0.15 squared, times the probability the last 2 are good, 0.85 squared, gives us 0.01626, the exact same answer we had before, as we expected. Now, what is the probability that exactly 2 are defective? Notice that exactly 2, that we could write here the probability that x equals 2, or I'll just say the probability of 2 defectives. That could be the first 2 defective, or the last 2 defective, or maybe even the middle 2 defective, or the first and third, or second and fourth, or last. There are several ways for this to happen. So what we need to know is how many ways to get exactly 2 defective. And to do that, we use a combin, as in a combination. We basically want a combination of 4 choose 2. From the 4 selected fuses, choose 2 of them to be defective, and that will give us the number of ways to get 2 defectives from 4. So combin, that formula is up here under formulas in the math trig, and you find combin, where the number of fuses is 4 and the number of defectives chosen is 2. We think of this as 4 choose 2, and that's 6. So now we just need to multiply this 6 with any one of the ways to get exactly 2 defectives, since they all have the same probability. So I'll just click on this version. And so the probability of exactly 2 defectives is 0.09754.